Hello everyone, I welcome you all for the lecture 4 of Understanding Data in GIS. This video is on behalf of Center of Excellence in Land Administration and Management, which is an initiative of DLRMP, Department of Land Resource, Ministry of Rural Development, Government of India. Currently housed at the Administrative Training Institute, Government of Karnataka, Mysuru. So in the last lecture series, we have discussed about how GIS can be beneficial for the land administration and management, and what are all the components involved in GIS, what is geospatial science and technology, what are all the technologies that involved in geographical mapping, and how it is going to be beneficial. All these things we discussed. So in this particular lecture we are going to discuss the main component of the GIS, that is the data. Without a data we cannot able to decide, or we cannot able to do the decision regarding the earth system. So what's happening around us that we need to know, means in such case we require data about the earth system and its dynamics, right? So as in the last lecture we have seen this flow chart where the GIS data broadly classified into two different categories. One is spatial data and another one is non-spatial data. The spatial data is relating to the space, where mainly the location of the feature and its dimension and its geometrical properties can be represented using the spatial data. And in the non-spatial data, the text, images, audio or video relating to the geographical space can be utilized. And the spatial data furthermore classified into two broad categories as vector and raster. The vector having three different properties, that is point, line and polygon, and the raster, which is the image based form. So in this particular lecture, we mainly concentrating on these spatial data, how vector data are formed, how raster data are formed. These things we are going to discuss. So if we look into the design aspects of the data mainly underlying behind the concepts of geometry, where geometry is the backbone of land surveying and geographical science in representing any data. So what is the key role of geometry in geographical science? So the geometry is mainly used to represent the geographical data, geographic entities, which are all stored in the form of geometric shapes. These shapes are nothing but the point, line and polygon. These are all the primary property of the geometry, where we can construct different types of shapes through these primary point, lines and polygon. The same concepts are inherited into the GIS, and we use the geometrical concept in order to represent the data in GIS. Comes to the next, the geospatial analysis. The geometry enables calculations like distance, the distance measurement from one particular point to another particular point with the help of the coordinates x comma y of a particular point 1 and x comma y of a point 2, so that the distance between two different points can be studied with the help of geometrical concepts. So we have different algorithms for that, the mathematical equations. Among that, one of the equation is the Euclidean distance, so mainly used to detect the distance between 2 points. Then the area, so the area of a particular land feature can be studied with the help of geometry and a series of coordinates that helps us to find the area. and the perimeter as well. Then the spatial relationship, how one particular feature is sharing the relationship with the other particular feature, and whether it is its intersection, proximity, adjacency. We have a lot of topological relationship in that, in order which helps us. The topology is nothing but the study of features. Topo means feature, logy means study. So which feature, geographical features and its relationship, the connection, how one feature is connected to another feature, adjacency, how it is neighboring, one feature is neighboring to another feature, containment, whether one feature contained in the another feature. So these type of complex analysis that can be done with the help of geometry. So that's what the geographical science is mainly depending on the geometry. So if we look into the geometry, we have two concepts. The one is the vector and another one is the scalar. So we all studied the vector and scalar in the elementary studies. So especially the vector in geometry, if we look into the vectors are used to represent a quantity that has both magnitude and direction. The vector is normally visualized in a graph. Vector between A and B is written. So now if you look here, the A and B, the point A and point B. So there is a line between the A and B. See, this particular line is nothing but the vector. The vector contains two property. One property is the direction. The direction of the vector is the angle it makes with the reference to the x-axis or with the reference to the you can say horizontal axis. So if direction is available and also the magnitude, the distance from one point to another point, the magnitude of a vector is its size or the length. So with the help of vectors, we can able to construct the line, we can able to construct the polygon. So that's what the two broader concepts in GIS, that is vector data and raster data. So vectors are nothing but the data which contains both magnitude and direction. So what are all the basic geometries are there in geometry? Right. So the basic shapes are the point and the line and the polygon. So if we look into the point data are dimensionless. So for the particular point there is no magnitude or there is no direction, but still it is a vector. Why? Because it contains the position of a particular location in terms of x and y. So points, it's an individual, a distinct point which is represented using the x and y location by taking the reference of x line and y line. So a number of points can be constructed and each point will represent a position of a particular feature in a geographical space. When it comes for the line data contains both magnitude and direction, and the unit is length, where the property of the line is length, where we can measure the distance from one point to another point. So what specifically the line is a interconnected vertices. So vertices is nothing but the point. So here this is a vertex, is another vertices. So if you look into this particular figure, four different vertices are there. So the alternative name for the vertices is the node. So here four nodes are there, four vertices are there, and The line connecting between two points are called as the links, or the edges. So different terminologies are there to discuss about the property of the vector. The line can be open. The open means the starting point of the line and the ending point of the line may be different. This is called open line, or you can call this as open traversal line, right? And another case is the line may be a closed traverse, where the starting point of the line and the ending point of the line will be same, but the property of the line will remain same, where we can measure the length of that particular line feature which we drawn. And often we have one more term along with the line is the polyline. See, if we have a straight line between 2 points, that is line. Suppose if a number of points are used to construct a line and there is some polygon nature where there is a bend in the line, in such case we can call that as a polyline. So if we look into this particular example, a Z like a structure, these are all nothing but the polyline where there is a bend in the particular side. So the straight line means a line which constructed using the help of two different points, that is just a straight line. But polyline means we have n number of nodes, n number of vertices that connected through the edges or connected through the links, which forms the polyline, but the property of the lines remains same. So these type of the lines can be used to represent the roads, or can be used to represent the stream, can be used to represent the electric line, UGDs, whatever the network lines. And the point also can be used to represent distinct features like the tower locations, the bore wells, the culverts, the permanent survey stones. These survey stones can be plotted with the help of point. And when it comes for the polygon is a closed feature where if you want to construct a polygon, minimum 3 points are required. Then when you connect all 3 points, the basic geometry will form, that is the triangle. So using a triangle, we can study the area of that. So the unit of the polygon will become the area. The area may be in a square centimeter, square meter, square kilometer, hectare, acres. It can be anything. So in especially in GIS we use polygon to represent the building boundaries, lakes, administrative boundaries, farm level land parcels. All these things are represented using a polygon. So in the if we look into the comparative statement between the point, line and polygon, the point is dimensionless, which is used to represent a distinct feature which is at a single location, that is the x and y. The lines are used to represent the networks like road, streams, UGDs, and others like a car track, foot track. Then if it comes with the polygon, the polygons are mainly used to represent the aerial features like water bodies, administrative setup, so and so. So the main property which is driving the point, line and polygon is nothing but the coordinate, and which coordinate system we are using. So in the upcoming lecture we are going to discuss in detail about the coordinate system used in GIS, and what is the governing principle, what will be the reference line that we are taking with respect to the earth. Since the earth is 3D in nature, it is in the form of a sphere, it is in the form of circle, ellipse, right. So in such case we have to use the different concepts to represent the coordinate on top of the earth surface. So this is the illustration where how the real world will look like. If we look into this, we have one landscape where this landscape have different features like three trees are there and one stream and one water body is formed and another one stream and again lawn area is there here. So here what we can see here is the with respect to the trees are distinct in nature, there is no continuity. So if we look into the point line or polygon, the point is very suitable for this to represent the position of the particular tree with respect to the x and y reference line. So the green color dots are the position of the tree in the geography, and we have a polyline. So polyline means there is no straight line concept here. There is a line, but a number of nodes or a number of vertices are used to represent the linear features. Now if you look into here, 1 2 3 4 5, so 5 vertices are used to represent this particular stream. Then furthermore the polygon, the water body, so which contains the area, which contains the spread. So this 1 2 3 4 5 6 7 7 points are used for sorry 6 points are used to uh, represent the water body and its extent. So the property will change. So in the case of the stream, the property will be the length. In the case of the water body here, the lake, the property will be the area. And here there is no length, there is no area with respect to the tree, just a coordinate information. So these are all nothing but the vector data all together to be called as vector data in GIS, which mainly uses a point, line and polygon to represent a geographical feature. And one more data sets we have in GIS, that is called raster data. It is an alternative to the vector, where vector is mainly used to represent the distinct feature. If we look here, the trees are distinct objects. It is not homogeneous across the study area. Even the streams are not available across the study area. So the sparsely it is available at certain location. So these are all to be called as the distinct data sets. But if we look into the raster data, the raster data are mainly used to represent the continuous natures of a geographical space, like the temperature. The temperature is continuous across the earth. So that means there is no single place without the temperature, there is a continuity. So when there is a continuity, those data sets, those variables to be called as a continuous data sets, like a temperature, like a humidity, like a rainfall, the elevation, the height of the landform above the mean sea level, it is continuous. And even below the mean sea level, the depth of the ocean floors, these can be represented with the help of raster data sets. So how raster data sets are formed? So if we look into the vector data formed based on the point, line and polygon. But if we look into the raster data is formed based on the grids which is designed to store the data. So we will see in detail what these grids are. So the grids are formed with the help of the matrix notation, where the matrix having the element, where individual element that we can call this as a particular pixel. So picture element. So this is mainly for in the form of image. So whatever we use in the normal camera, the selfie that we capture, whatever the photographs we are getting, those photographs are nothing but the raster data. The technical word is raster, but for the general public we say that as a picture or a image. So an individual cell, so this particular grid can be called as the cell, which represents the portion of the earth such as a square meter or the square mile. The aggregation in this particular area, what will be the elevation above the mean sea level, that is recorded at the particular grid or the cell. And again, if we look here, 30.6 is the average elevation above the mean sea level at this particular corner. So there is a continuity in elevation above the mean sea level. When there is a continuity, then it is good for us to use the raster data to represent the continuous features like elevation. If we look into the raster data are formed using a series of rows and columns. Where the rows and columns are intersecting, we call that as a picture element. So this picture element have an ability to store only one value. That value is called digital number. Like in the previous examples we have seen here. So this is the digital number, whatever it is stored within the pixel. And each pixel or each cell or each grid can be identified using the latitude and longitude of the particular pixel with respect to the reference line. So this is the closer view where the satellite imageries are captured from the space, and this is also in the form of images. If we look closely, the series of grids are formed, and each grids has a pixel value. That value is called digital number, and digital numbers are stored. So what these digital numbers represents? These digital numbers are nothing but the reflected energy from the earth surface, that is quantized and calibrated values. So the sensor mounted to the satellite will have a capability to receive the reflected energy or to receive the emitted energy from the earth, and it will record the energy into equivalent value according to the design of the satellite or the sensor. So like our human eye can able to see the colors. So how we can able to see the colors? Because of the illumination from the object with the help of natural sunlight. So if there is no sunlight, then there is no reflectance. So in the dark room we cannot able to see anything. Why? Because there is no reflection from the particular object. Suppose if we illuminate the room, then whatever the objects in the room, that can be easily visible to the human eye. Why? Because that particular object is illuminating some energy. That energies are recorded by our sensed by our human eye. So similarly, with respect to the example of human eye, the sensor has a capability to record the energy emitted or energy reflected from the earth surface. So these values are nothing but the digital number. So this is the comparison between the representation of both vector and raster data. So we have a vector and we have a raster. Since the well or a tower or an electric pole or a cell phone tower all are distinct in nature, the point is enough to represent the particular tower. So in the vector data we use just a point data, one point. But if we want to represent the same well or tower in the raster data, then the particular grid is encoded with the particular value, and the remaining cell not encoded with the values. So you have to form the image, and wherever the data are available we have to code it. So if we look into the line, so there is a line that is formed using 5 different nodes, 5 different vertices, and connected by a series of edges or the links, and here the single line polyline is formed. But if you want to represent the same line in the raster data, then wherever the lines are passing, those pixels need to be coded with the value, and the remaining pixels will be coded with the node data. Again with the example of the polygon, the pond built up whatever the polygon. So wherever polygons are passing, those pixels need to be represented coded with the particular value. So there is a certain advantage and disadvantages over using the raster and vector data. So we will see that. The advantages of vector is, once you create a particular point, That point can be integrated with n number of information that you want. Let's take an example. You went to the field and you collected the latitude and longitude of a particular tree. So the spatial information is captured. Then the species of a tree, what is the height of the tree, what is the age of the tree, what is the girth size of the tree, all the information can be integrated with the particular point. So that means there is an advantage of data integration with respect to the vector data. But in the case of raster, the ability of the raster is to hold only one value, that is called digital number. You cannot able to store more than one value with respect to the raster data sets. But in the case of vector, you can store n number of thousands of information within one particular point, line or polygon. So by this I am going to end the lecture 4. I guess you got some idea about how vector data or the raster data are formed and what are all the advantages and disadvantages of the usage of vector and raster. So in conclusion, generally if you want to represent geographical features distinctly, like the roads, the buildings, the trees, the different point of interest, whatever, then in such case you can go with the vector data. Suppose if you want to represent the temperature of a city or rainfall pattern of a city or the elevation pattern of the city, these types of information can be represented using a raster rather than the vector. So we should know to distinguish whether we want to use the vector data or raster data for representation of the geographical feature. So thank you everyone, and please visit us at our website by scanning the QR code and follow us at the Instagram, YouTube, LinkedIn, and if you have any queries you can write us to our mail ID. And by this I am ending this lecture. Thank you.